Hello engineers, welcome to a new video on low-level design. In this video, we'll look at a new pattern called the Iterator pattern. I hope you're ready. Let's get started. So this is the intent. Provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation, right? So this is a very simple pattern actually. It is a way to iterate over something. So this something can be anything that has a list of elements, right? So there can be a bunch of elements in this and I want to access them sequentially, right? And I can access them in multiple different ways. I can go from left to right, I can go from right to left, maybe I'll start from the middle and so on, right? So there can be different ways I can access the elements of this particular thing, right? But if there are different ways, why don't we separate out the algorithm that does the iteration from the main object? Right? So that's the whole idea behind the iterator pattern. So let's try to understand this with some example use cases. So the first example is data structure traversals. So any type of data structure, right? If it's having a bunch of lists, we can traverse through it. For example, we can traverse through an array, we can traverse through a linked list, we can traverse through a tree. Tree can have multiple things. There can be binary search tree, there can be binary tree, black tree, red tree, and so on, right? There can be a bunch of things like that. And then we can also traverse through graphs. So how do we traverse through graphs? We can traverse through breadth first or depth first. We can also do this for trees as well. So there can be different data structures that we can use. And because they have a bunch of elements, we can choose to iterate over them in multiple different ways. So the iterator pattern provides a structure so that the iterating logic or the iterating algorithm is decoupled from the main object. See, the main aggregate object. So aggregate is nothing but something that has a bunch of elements, right? So without exposing the underlying representation, which means without exposing the underlying algorithm, we can iterate over the aggregate object sequentially, right? That's the idea behind the iterator pattern. So another example can be database query results. So when we are trying to fetch a large amount of data, usually it is an array of objects, and array of objects can be iterated one object at a time, or we can iterate over a block of objects at a time using pagination and other techniques, right? So we can use the iterator pattern in that scenario as well. And then there are many applications with infinite scroll feeds. So Twitter, Facebook, Instagram, YouTube, right? So as we scroll, we get new things coming up onto our screen. So there is a bunch of things that are loaded up front, and as we scroll through, the top ones are removed from the buffer, and then when we reach the bottom, the buffer is refilled with new content, and we can keep on scrolling through this list. So in this situation as well, we can see the iterator pattern being used, right? So these are some of the examples. Now let's see how to use this pattern, how this pattern is implemented using UML diagrams. Let's go to UML now. So this is the class diagram of the iterator pattern. So on the left side, we have the aggregate. So this can be an array or a linked list or anything. It will hold some kind of a list of elements, right? And it will create a bunch of iterators. So iterators are the different algorithms using which we can iterate through this list, right? And because we have different algorithms, we will create each method for each type of iterator. And what is an iterator? Iterator is an interface that can be implemented by a bunch of algorithms. For example, if you are building a tree can be iterated depth first or breadth first. So iterator A can be depth first, iterator B can be breadth first, right? And if you look at it closely, the aggregate is part of the iterator. So whatever is the aggregate is part of the iterator. So the tree is available here, and because the tree is available here, we can call upon these common methods called has, next, and next. So has next is a Boolean function which returns if there is any pending item in the list. If there is any next item in the list, if there is, then we will simply return the next item, and so on. So this is a common pattern. So the iterator interface exposes two methods, has, next, and next. So as long as has next is true, we can keep on going through the list. Very simple implementation. Again, there can be variants of this, but the idea is to have a common interface, to have multiple algorithms adhere to this interface so that the list can be iterated. So depending on the list, these functions may change, but the structure is the iterator pattern, right? So that's how the class diagram goes. Now let's see the sequence. So the client will create an aggregate, some kind of a list of elements with arrays or arrays of numbers or linked lists with nodes and so on. And it will create a iterator. And while creating iterator, it will specify which type of iterator it wants, whether it wants to iterate over the array in a forward way or a reverse way and so on. So the iterator instance is returned. And once the client has that iterator, it can call upon the methods within the iterator, has next and next. And within the iterator, we already have the list of elements, so we will simply iterate over it one element at a time. So this is how we can sequentially access each element within the list. So this is the sequence diagram. Now let's see a simple example to understand this pattern. Let's say we have an array of numbers, right? Very simple array of numbers. And this array can be iterated from left to right or right to left, which means it can be iterated in a forward direction or a reverse direction. So we create two types of iterators. So forward iterator and reverse iterator. Forward iterator will start from 0 all the way to the end of the array. Reverse iterator will start at the end of the array and all the way back to 0, right? Two different types of iterations following a common interface called iterator, right? So because we have two different types of iterators possible, the class holding the array will expose two methods: create forward iterator, create reverse iterator. So the client can choose whichever iterator it wants to use. So let's say it is calling create forward iterator. So this will return an instance of this object. And this forward iterator will carry the collection object, which will in turn carry the list of numbers anyway. So it has access to the private members. So it can go through the list of numbers by using these functions has next and next, right? So this is a simple implementation of the iterator pattern. Let's see this in code now. So I'm in VS Code now and we have iterator.cpp. So let's see how it goes like. So first we have the iterator common interface, which has two methods, has next and next, right? And this will be implemented by our forward iterator and the reverse iterator. And now let's see the class. So we have a number collection. It has a array of numbers, right? And it will expose two methods, create forward iterator and create reverse iterator, okay? And these are nothing but our iterators, which are implementing our iterator interface. So let's see. So the forward iterator and the reverse iterator take the number collection as part of the constructor and hold them within the private space. And in the has next function, it has to return a boolean if there is any next element to be accessed. So for this, it will make use of the get size function of the collection to check if the current index is less than the collection.get size. If it is less, it will return true, otherwise it will return false. Very simple. And for getting the next element, it will call upon the collections get number method using current index, and it will do plus plus so that the index is incremented, right? So we are going forward by incrementing the current index. And what is this current index? It is something we will start at 0 to access the first element first, because we are in the forward iterator. So we start at 0 and the first next will return the index 0 and it will increment the current index. Next time when somebody calls has next, it will return true if there is more elements. It will get the next element at the current index and index is incremented, and the loop will continue as long as it's required, right? Similarly, if you look at the reverse iterator, we will start the current index at the size of the array, and when we call upon the next method, we will do get number at current index and we will do current index minus minus, because we are going in the reverse direction, right? Cool. So simple implementations to understand the iterator pattern. One is going from left to right, one is going from right to left. Now let's see the usage. Let's say this is the client, the main function, and it has created 5 numbers into the array, right? And it can iterate over it in two ways, forward and reverse. So first let's create a forward iterator. So this returns an object for forward iterator, which has two methods, has next and next. So here we can use the loop now. As long as forward iterator has next is returning true, we will simply call upon next. This way we can access one element at a time from the array. Similarly, we will use the reverse iterator. We will get the object of the reverse iterator into this reverse it variable, and we can again use the loop. While reverse it has next is true, we will keep on calling next. right? And this is starting from the end of the array and doing index minus minus, as you can recall. And once it hits 0, this is becoming false and the while loop is exited, right? Simple. So by just calling the create iterator methods, we can change the algorithm of iteration, right? So we have decoupled the iteration logic from the main collection so that it can grow on its own and we can add as many algorithms as we need to. So let's run this and see. So forward iteration 1 2 3 4 5, reverse iteration 5 4 3 2 1, right? So both algorithms work just fine. So this is a code implementation of the iterator pattern. Very simple. Now let's see some trade-offs. So with the iterator pattern, we get clear separation of concerns. The iterators, the algorithms for iterating over the list is separated from the main aggregate class anyway. So we get separation of concerns. So this is following the single responsibility principle in a beautiful way. And we also get memory efficiency because we only need to create those objects which are required for iteration. So if we put all the algorithms inside the main class, we would have created an object very large. But by decoupling, we have reduced the memory usage as well. And it is open to multiple iterators, obviously, because iterators can be added at any time. And this is following the open closed principle. So we get these great strengths from this pattern. And coming to weaknesses, we have more classes to deal with because instead of one class, we are having to deal with additional classes for iterators, and that is an overkill for simple applications, right? So these are some things to keep in mind. Okay, so in this video, we have covered the intent of the iterator pattern. We have seen many example use cases, the UML diagrams, the code walkthrough, and also the trade-offs. So if you have any inputs or questions or suggestions, definitely put them in the comment below. I'm always reading through the comments. Thank you so much for watching, guys. I will see you in the next one. Do leave a like if you found this helpful. Do subscribe to the channel if you haven't done already. I will see you in the next one. Cheers.